Welcome again, guys, to another flipped lesson. What we'll be doing in this lesson is learning the difference between the words element and compound and focusing on the idea of what a chemical formula is and what it can show us. Because in chapter 4, what we're going to start to do is name and make these ionic and molecular compounds. So we have to have a general working knowledge of the things and pieces that make those compounds up. So our main focus for this video is distinguishing ionic from molecular compounds. Here we go. The first words we need to kind of separate from each other are the idea of an element versus a compound. So if we say the word element, what we're referring to is the stuff on the periodic table. So that's all those elements that we've been dealing with in terms of figuring out their arrangement the past couple of days. They can be monatomic or diatomic, and what we mean by that is they can exist as a single atom in nature, or they can be one of our Hankelbrief atoms. So examples of monatomic atoms would be things like sodium, gold, silver, things of that nature. So typically your metals or your metalloids. Your diatomics are going to be your Hankelbriefs. So H2O2, N2, Cl2, Br2, I2, and F2. So these are still considered elements because they're just two atoms of the same element combined together. So a monatomic element is going to be a singular element like a metal, where a diatomic is going to be your Hankelbrief atoms. Now what we can do with those elements is we can join those atoms together to make a compound. And what a compound is going to consist of is two or more different elements. And this is the important part of that definition, the word different. If you have H2, you have two elements, but they're the exact same. So it's not a compound, it's an element. In order for it to be a compound, it must be at least two different elements stuck together. So examples of different compounds would be like water, H2O. Our two elements would be hydrogen and oxygen. You could have something as complex as glucose, C6H12O6. We have three elements there, carbon, hydrogen, and oxygen. Or something like table salt, NaCl, where our two elements there are sodium and chloride. So in order for you to have a compound, you have to have at least two different elements bonded together. An element is just going to be a singular thing. Now, what does a chemical formula like H2O or NaCl actually tell us? What it does is it shows us the kinds and numbers of atoms in a compound. So if we're looking at that formula for H2O, that chemical formula tells us that we have two hydrogens with this little subscript 2 and only one oxygen because there's no subscript in the back. So a chemical formula shows us the number of each type of element that we have and then the number of different elements that make up that compound. It does not tell us anything about how those things are actually stuck to each other. So it doesn't show us how the atoms are arranged with each other. It just tells us the number and type of atoms we have present. Now, how do I work with knowing whether my formula is for an ionic compound or for a molecular compound? For you to be a molecular compound, what you're going to be made of is something called a molecule. So you're going to want to write this in your chart. And what a molecule is it's two or more atoms bonded together that behave as a unit. It's the smallest unit that still has the same properties. But the most important thing about your molecules is they're going to be nonmetals. So everything that's in that formula is going to be a nonmetal. So here we can see we've got C with two O's. So this is showing us carbon dioxide. Carbon and oxygen are all nonmetals. N2 is considered a molecule because we just have to have two or more atoms in a molecule. They don't have to be different. So your Hankelbrief are molecular elements. They're molecules because they're two atoms stuck together, and they're elements because it's the same type of atom. So a compound and a molecule is just a slight difference. Compounds, you have to be different elements. Molecule, you just have to be more than two things stuck to each other. If you're an ionic compound, what you're made of ions. And what an ion is it's a particle that has a positive or negative charge. And that's really, really important. How you make those ions is going to be the focus of the next video you're going to watch. And it's made by gaining or losing electrons. So an ion is going to be a particle that has either gained or lost electrons to take on either a positive charge or negative charge. Now, like we just talked about in the last slide, for you to have a molecular element, you're going to be made from bonding metals and two nonmetals together. So your molecules are always going to be nonmetals all the time. So when you're looking at a compound and you're trying to figure out if it's ionic or molecular, if the only type element you see present is on the right side of the periodic table, so your gases typically, things like nitrogen, oxygen, sulfur, fluorine, it's going to be a molecular compound. Nitrogen is nonmetals, so it's a molecule. C's and O's are nonmetals, so it's a molecule. How you distinguish something that's ionic is it's made from bonding a metal and a nonmetal. Now here's the cool thing. Your metal ion will always come first. So when you're looking at an ionic compound, so for example NaCl, our two elements are Na and Cl. Sodium is our metal, and the Cl chlorine is our nonmetal. The metal will always come first in that compound formula. So if you're trying to distinguish between if something's molecular or if something's ionic, look at the first element in the formula. If it's a metal, it's got to be an ionic compound. If it's a nonmetal, it's got to be a molecular compound. So here's what I'd like you guys to try really quick in your notes. I'd like you to look at these four compounds and to tell me whether you think they're going to be ionic or if they're going to be molecular. Go ahead and hit pause now, and on your own, see if you can distinguish if it's going to be an ionic compound or a molecular compound. So you're back. I'm guessing that you've gone through and you've identified ionic versus molecular. So let's see how you did. This first one, MgO, Mg is on the left side of the periodic table, meaning it's a metal. So this must be an ionic compound. In our second compound, P is a nonmetal on the right side, so it's going to be molecular because these are both nonmetals. S, again, is a nonmetal found on the right side of the periodic table, so both S and F are nonmetals, so this one is molecular. And last but not least, Sr is strontium, which is a metal in the alkali earth metal family. So this is in fact going to be ionic. So when you're trying to distinguish ionic versus molecular, you just have to look at the first element and see if it's a metal or a nonmetal. I hope this gave you a little bit of an idea what compounds can tell us and what the two different types of compounds we have are. In the next video, you're going to go ahead and learn how to make ions. There's no Google form for this one, so go ahead and just watch that second video, fill out your notes, and answer the Google form questions. Have a great night, guys. Oops, Alt-P. I forgot to hit pause. Really goodbye this time.